Class, we have discussed the law of conservation of mass, that matter can never be created nor be destroyed. We have discussed the law of definite proportion. What it means, if we take a definite compound, the ratio of the masses of different elements present in it is constant. This is law of definite proportion. Today we will discuss law of multiple proportion that was given by Dalton in 1803. Let us discuss. Law of multiple proportion. It was proposed by Dalton in 1803. What this law says? This law says that when two elements combine to give more than one compound. When two elements combine to give more than one compound, then the masses of one element that will combine with the mass of another element will vary in whole number ratio. Let us see. That means this law states that when two elements combine to give more than one compound, then the masses of one element that will combine with the fixed mass of other element will vary in whole number ratio. Let us discuss what this law says by taking an example. I have stated that the law of multiple proportion says that when two elements combine to give what? More than one compound, then in that case the mass of one element that will react with the fixed mass of another element will vary in a simple whole number ratio. What this law says, let us discuss by taking example. If we take an example that what hydrogen react with oxygen, then it forms water. We can write it in the form of what? H2 react with O2 is to give H2O. When we balance it, what you got 2H2O like this. What we see here? We see here, the next we have the example. Hydrogen react with oxygen, the same element. Hydrogen react with oxygen to give H2O2, hydrogen peroxide. And we have stated that when two elements, these are the two elements, hydrogen and oxygen, combine to give more than one compound. This one is water and this one is hydrogen peroxide. What we see here that the mass of one element that will combine with the mass of another element will vary in simple whole number ratio. Let us see it. Here, what we are taking, 2H2 plus O2 is to give H2O. That means we can say 2H2O. But for simplicity, we can write what? We can write H2 plus O2 is to give H2O2. What we can write? We can write that what is the mass here? 2 to the 4 gram. 4 gram of hydrogen react with 32 gram of oxygen to give water. And that is what? 18 to the 36 gram of water. For simplicity, we can also write that what? 4 gram of oxygen react with 32 gram of oxygen to give 36 gram of water. To the next, you can write, you can also write it as when 2 gram of hydrogen, when simplified, 2 gram of hydrogen react with what? 16 gram of oxygen to give what? 18 gram of water. What we have? It is so simple. What we see? 4 gram plus 32 grams to give 36 gram. When we simplify it, what we got? 2 gram hydrogen react with 16 gram of oxygen to give 18 gram of water. The next, what we see here in the next one, it is same. When 2 gram of hydrogen react with 16 gram of oxygen to give 18 gram of water. To the next, what we see here, when 2 gram of hydrogen react with, what is this one? 32 gram of oxygen to give 34 gram of water, hydrogen peroxide. What we see? We have discussed that when two elements combine to give more than one compound, that is happening here. Two elements, hydrogen and oxygen, to give more than one compound, that is water and hydrogen peroxide. Then in that case, we have discussed that the mass of one element, here 16 gram, that will react with the fixed mass. Fixed mass, what we have? 2 gram of hydrogen here and 2 gram of hydrogen here, will vary in simple whole number ratio. It means it is 16, it is 32, that means it is 16 2 ja. It means it is when it is multiplied by 2, then we get the next compound. It means it will vary in simple whole number ratio, not in fractions. Clear? What we know? We know that 2 gram of hydrogen, here 2 gram of hydrogen react with 16 gram of oxygen, here it is 32 gram. It means the mass of other element that will react with the fixed mass of one element will vary in simple whole number ratio. Let us take another example. For example, carbon react with oxygen to give carbon monoxide. It means what we see here, 12 gram of carbon react with, what is this, 16 gram of oxygen to give 12 and 16, that is 28 gram of carbon monoxide. To the next, we will take when we take carbon, when it reacts with oxygen, it will form carbon dioxide. What we see here, it is 12 gram and it is 32 grams, forms 44 gram of carbon dioxide. What we see here? We see here what? When two elements combine to give more than one compound. There are two elements, carbon, oxygen, carbon, oxygen. When they combine, they give more than one compound, carbon monoxide, carbon dioxide. Clear? Then what we see? We see that the masses of one element, that will combine with the fixed mass. Masses of one element, that is oxygen, that will combine with the fixed mass 12 gram, 12 gram. The masses of one element that will combine with the fixed mass of another element will vary in simple whole number ratio, that is 16 to 32. This is all about the law of multiple proportion. Let us discuss the next law, that is Gay-Lussac's law of equal volume. Of equal volume. These laws is applied for gases. It states that when gases combine or produce in a chemical reaction, then they do so in the ratio of their volumes. Clear? Let us see. When gases react or produce in a chemical reaction, then they so in the equal ratio of their volumes, provided that they are at same temperature and pressure. The Gay-Lussac's law states that when gases react or produce in a chemical reaction, then they do so in the equal ratio of their volumes when they are at same temperature and pressure. This law is only and only applicable for gaseous reactant and product. Let us see what this law says by taking an example. For example, we see when hydrogen react with oxygen to give water. When we see what is the cytometric ratio, we see here 2:1 is to give, what is that one? 1 is 2. What it means? It means when two volume of hydrogen react with one volume of what? Oxygen. Then it gives, what it gives? It gives 2 volumes of water. I have stated this law is applicable for gaseous reactant and product. You see here it is in gas state. It is in gas state, and this, as a result of this reaction, large amount of heat is produced. That's why this is also in gas state or vapor state, you can say. What we see here, 2 volumes of hydrogen react with 1 volume of oxygen to give 2 volume of water. What it means? Let us see it. It means we can say 100 ml, let us take example, 100 ml of hydrogen react with 50 ml of oxygen to give what? To give 100 ml of steam, water. This can also be understand when we have same volume, when we take 2 volume of hydrogen, 1 volume plus 1 volume, the same volume we have, plus 1 volume of oxygen is to give, what is that one? 2 volume of water. This is all about the gaseous law of equal volumes, what we have studied. Let us discuss the next law, that is known as Avogadro's law. What this law states, according to this law, equal volume of different gases at same temperature and pressure. What we have? The temperature and pressure is same, and if we take equal volume of different gases, then they have same number of molecules. Clear? Let us discuss it. That according to this law, equal volume of different gases at same temperature and pressure have same number of molecules. That is, let us understand it by taking an example. That is, at STP, what we have? 1 mole of any gases occupy 22.7 liter. It means at STP, 1 mole. If we have 1 mole of any gases, hydrogen, oxygen, carbon dioxide, whatever it may be, it means 1 mole of any gases occupy 22.7 liter volume. What we see? We see that at STP, if we take 22.7 liter of any gases, then they contain 1 mole molecules. This is all about the Avogadro's law. What is that? That the 1 mole of any gases at STP have same volume, that is 22.7 liter. Let us discuss Dalton's atomic theory. As you have studied in class 9th, what is Dalton's atomic theory? That matter consists of indivisible atoms. It means the matter is composed of teeny particles which cannot be divided. He named it as atom. It is derived from the Greek word atomio. It means indivisible. He also states that the atoms of a given element are identical in all the respect. That is, they have same masses. But the atoms of different elements have different physical and chemical properties. He also said that when atoms of different elements combine together in a fixed proportion of their masses, then they constitute compound. Let us discuss the Dalton atomic theory one by one. The first is that Dalton's atomic theory. Dalton atomic theory. The first one is that the matter consists of indivisible particles known as atom. The next is that, but we know nowadays atom can be divided into electron, proton and neutron. It means this statement of Dalton atomic theory is being discarded. The next one we will discuss all the atom of a given element is identical in all respect